Hey guys, it's Vince. Today in this video we are going to be discussing how to add switches inside of Pumotix. So what we're going to do is double click on the Pumotix icon on our desktop. And as Pumotix opens, I'm going to select the 6-axis screen set. Again, I do have all of the modules so you can see all the options I have. I am using version 3.5, which is the latest version. And again, I'm going to choose the light theme as far as screen set color. Go into OK. OK, got our Screaming Chicken up. I'm going to go to Configuration, go to Settings. Once again, I am in simulator mode. Many questions are coming in with that, and what that simply means is I do not have the PLCM controller connected. I recommend actually setting your system up in simulator mode, and you can always connect the PLCM later. I will say this, before you guys install any hardware on your robot, regardless of what software you're using, you should be testing everything with the software off of the robot prior to installing it. This is best practice because if you encounter a problem, it's much easier to fix than when you have it already mounted to the robot. I can't tell you how many people do this. I don't understand it. And I'm telling you right now, it's going to save you a lot of time. Best practice, leave the hardware off the robot. That includes motors. Test everything and then mount them. And in this way, you have a point of reference that you know everything worked prior to you actually installing it on the actual robot. So now what we're going to do is come over to the Motors tab. You can see I've allocated NEMA 23 600 ounce as the X-axis, Y-axis, and Z-axis motors. Now I highly recommend you guys actually use the option to name your motors, whether it be by the size of the ounce inches that they produce or whatever determination you want, part number, whatever it may be. And I'm going to tell you why. The main reason why is that you always have a point of reference once again, should you have to reorder a part. I can't tell you how many clients of mine will come back to me and say, Ben, I need to order a motor, I just don't know which one it is. Is it the small one, the big one? Is it NEMA 34, NEMA 23? You put this information here, you'll have it forever, and you'll never have to worry about, oh, I can't remember what part number. These are just best practice to always record everything, and best of all, the software lets you use your own terminology. So again, super powerful. Use the option that's included. That being said, you can see here where we've got our additional signals. If you're installing Pumotix for the first time, you'll find that there are some default signals already there. You do not have to start with them, and I highly recommend you just take them off and then naturally modify the software based on your system. Now you can see here ADD.signals is just an abbreviation for additional signals. We've got our boxes here. You can see if you leave the mouse cursor over the box, you can see that the hint comes up that says remove signal from selected motor settings. We're going to start fresh, so we're going to just simply go through and click on that box. Are you sure you want to remove this signal? Yes. We're going to do it for them all. Okay, go to the next axis, same thing. And go to this axis and same thing. And go here. Boom. Okay. Now you can see here that we've got all the different types of signals that we can add for options for each axis. So first, let's just arbitrarily, we'll select the X-axis. And if you come over here, once again, you're going to get hints. You can see that this is for the enable signal output. This is for a home sensor for that axis, and we can see if we read this, input signal for the home sensor of the motor. And then it says the sensor is used to determine the reference point in the machine coordinates. Most of you, if you're going to use a physical switch, this is what you're usually actually using it for. This, and also limit low. Input signal for low limit sensor of the motor. The lower sensor registers the output over the dimensions of the working area in a negative direction. Then you also have a limit middle, input of the middle sensor of the motor. The middle sensor is located on the border of the two working zones of the CNC machine. So basically splitting the axis in half if you chose to do that. Then we have a limit high. Input signal for the high limit sensor of the motor. The upper sensor registers the output over the dimensions of the working area in a positive direction. So you can see limit low and limit high are essentially both the negative and the positive portions of the axis as far as how it's going to move. So for this example, and again, it's all the same, I'm going to choose a home actual switch. So we would just click on the home signal. And you can see here now we have an exclamation point in yellow. It says signal not configured. So you just click on that. And you can see once again the actual definition is popped up as it was over here when the home switch actual signal was here and available to click on. You can see it's gone now because we've already allocated it. Now what we're going to do is select what pin number is associated for this axis. Now, if we're using a G540, and I'm just using that drive as an example, using a breakout board, you would select whatever pin number you want for that. On a G540, if we used input 4, it would be SIM pin 13. And the only reason it'd be SIM before pin 13 is, of course, we don't have the PLCM connected, so we're in simulated mode. That means before every pin number, you're going to see the abbreviation of SIM. Totally normal, just letting you guys be aware of it. Inversion is just to invert the signal. Once again, leave your mouse cursor over it. It's going to tell you and define exactly what this will do. This will let you, if your LED is not lighting up on your diagnostic tab, you would invert the signal. If you're not happy the way something's wired, you could also reverse the wiring. It's totally up to you. But you can see here, after we've done all this, we've already got now the signal is allocated to our x-axis. And we can see that with this icon that resembles a Monopoly house, which again symbolizes our home symbol or home signal. So now we're going to click on apply. As we do that, we get the typical warning: for correct operation required, then only one function is defined at each output. Device pins used for multiple functions, SIM pin 13, click OK. That's totally normal. And then we're going to click OK again. And we get the warning one more time. We exit out of that. Now what we are going to do, come back over to configuration. I'm going to go to settings. Now what we want to do is go to our I/O tab for input outputs. Come over here to our input signal parameters. Now, just so everybody is aware, this is the visibility tab, and this symbolizes what's going to be visible in your diagnostic tab. And once again, if you leave your mouse cursor over this, I've described this in previous videos where we actually modified our diagnostic tab to only reflect what we would have connected to our robot. Makes it easier, cleaner. And you can see here, this is what it's explaining. If you come over here, it says visibility in the diagnostic tab. You're going to scroll down to input 4. And why I say input 4 is because, again, that's where we allocated the x-axis home signal. Now, if you come over here, you can see description. And I'm going to show you just how powerful this is. We'll say home axis signal. And there we go. So if we say that, and we're all set there, we're going to come over here, and we are going to once again say that we need pin 13, and the reason we're using SIM pin 13 is we know that on input 4 on the G540, once again, it's got to match the pin number that we've allocated to the home signal in the previous tab. And why we want to do that is so that the LED is then registering in the diagnostic tab with the switch that we've assigned. So again, it all corresponds, it's all corroborating, and you're all set. So again, you can name this whatever you like. It's totally up to you. I myself prefer to use a terminology that I'm very familiar with, and I love being able to do this for each individual because everybody likes terminology that they're more familiar with. So it's just easier that way. We'll click on apply. We'll click OK. And then once that's done, we're all set here. We're going to click here again. You get the warning message, and that's all set. Now, if we come over here to Diagnostics, you can see it says home axis signal instead of user input 4, and it's actually in the correct position. You can see it's between input 3 and input 5, and you can see the LED is not lit. Now, the reason the LED is not lit, of course, I do not have a switch connected. You guys now will validate whether or not your switch is actively connected by seeing if this LED is illuminated when you depress the switch. This is best practice. It should look like this. This is the color of the LED. So again, very, very straightforward process. Very easy to understand once you've gone through it. And if you follow this process, once again, of testing all the hardware prior to installing it, you'll never have any issues. And again, the inputs or the input signal state and the output signal state, you can see how clean it is from what I've done by providing limited visibility on the I/O screen so that, again, you have just what you would require for your robot. You may not have all of these inputs, nor would you need them. Therefore, take them off. Keep only the input signals visible that you're going to use for your robot. It's going to make your screen neater, and again, it gives you less confusion. And less confusion means you guys can digest just the information you need, which makes you twice as efficient. I'm telling you, trust me on this. So again, you can see exactly how this was done. Now, I have a couple other things I'd like to discuss. We'll go back into settings, and we'll go over here to motors. Now, Regardless of what signals you decide to go with, if you go at limit low, limit middle, and limit high, you also then have the option to click on the advanced settings. Now I can't do it because I did not select any. So if I was to add a limit low also to the x-axis, and I configure it arbitrarily, we'll just say sim pin 5, and then we'll go apply, get the warning message. Now if I click on this, and I go like this, I can come over here and click on use limit low as soft limit. This is an advanced setting. And what it does, stopping the current engine will be performed without going to e-stop. Further movement towards the sensor will be impossible. So basically it's working as a soft limit, and that's exactly what it's defining. Okay, lots of questions pertaining to this. Very, very simple to understand once you've done it. And again, my recommendation, and this is why this is so powerful, is leaving the hardware dismounted from the robot allows you to test all these settings and see what each one does and give you the definition right there in front of you. And in this way, you're learning as you go before you mount everything to the robot. And again, if you use this method that I'm discussing, you're teaching yourself by true definition because you're seeing the actions that each one of these settings create as you set them. This is super powerful, seldom discussed. That's the difference between the more advanced users. They understand this principle and they practice it. And I highly recommend you guys start with that because I'm telling you, it'll really streamline the learning curve. So once again, I cannot set it for use limit middle as soft limit, use limit high as soft limit naturally because this we only set up as a limit low. These are only allocated to their specific signals. So if I did a limit middle, then I could do the limit middle. If I do the limit high, then I can set the limit high. Very, very simple, straightforward, and logical. So now what I'm going to do is just remove this. And I have one other area I'd like to discuss. You can see here where it says software correction of homing switch in inches. This is super powerful. If you guys who are running a slave axis, where you usually have the A-axis running in conjunction with your Y-axis, which is the long axis, and that both motors are required to automate the Y-axis, inside of Pumotix, we'll get out of here, and we'll go to configuration, and we'll go to calibration wizard. You have gantry alignment calibration. If you were to do gantry alignment calibration, and again, I'm saying the y-axis, but in theory, this would work on virtually any axis. If you do the gantry alignment for the slave axis, you can see 2 points here. Most of the time, with guys using this type of configuration, they're using a switch to offset to keep their axis in a square calibrated state. This software will not only allow you to use the switches, but also allow you to fine-tune. And you can see here, select 2 motors axis, portal axis, and set parameters of the calibration quad in the gantry width field. Specify distance between the base sensors. The system will move step by step to each vertex of the quad with the stop to set to the mark. And all that simply means is when you guys square everything up and do your calibration, whatever off percentage it is as far as in inches, because that's my measuring matrix, or it could be in metric depending upon your measuring matrix, you would see that that offset would be actually disclosed right here, software correction of, and it would actually give you the software correction population right here. Very, very powerful. Okay, I'm telling you right now, I don't know any motion control software that does that. It was something that the engineers and I discussed, and it makes logical sense, and it's something that is really inevitable. No switch is manufactured to perfection. Nothing is, for that matter. They all have variables. They all have manufacturing issues. You may have a mount that's slightly off by a couple thousandths. You want to keep that gantry as square as possible when you're running 2 motors. And again, this procedure, if you were to use the gantry calibration, that's to bring you into tune, so to speak. So again, very, very powerful, but I've made it very clear, I think, on exactly how to actually add whatever signals you like and allocate switches. And you saw how easy it is. And again, when we just come out of here, click out of here, we know what we're doing now. We can come to our workflow process, and you guys are all set. So again, guys, as I do more videos, once again, I'm hoping that you guys are benefiting from them. I have an entire library now basically created for Pumotix, and I love it because it's going to make your learning curves that much better. If you have a question, search my channel, and whatever it is in Pumotix, it'll pop up. And that's the whole goal here, is it's leveraging my time because it's making me constantly available to you for support, and in digital format I can do it with you. So again, I know videos usually add more questions to the mix, so to speak. If you need to contact me, please contact me direct at storm2313@gmail.com. That's my direct email, and that's for questions, comments, quotes. Also, you can contact me through my eDealers direct eBay store. You'll see links in the beginning of the video and at the end. Thank you all for your support. I hope this has helped you. Take care.